Alright, so section 8.2 is on matrices. And matrices is plural for the word matrix. A matrix really is just a table. And for our class, it'll be a table of numbers. I don't think I've seen matrices that have anything other than numbers in them, but I suppose they could. I just can't think of a time where I've seen one. And a matrix can be used to represent and solve a system of linear equations and that's what we did in sections 8.1. We solved systems of linear equations, and we can use a table of numbers to represent and solve that system of linear equations. I don't know if this is going to be a complete sentence, but it is much more work to use matrices to solve systems of linear equations. It's like twice the work. So they're not my preference to solve systems of linear equations, but there's a certain structure in the way that we solve systems of linear equations with matrices that lend itself to computers and technology, and this is a big deal because then of course if I'm using a program like Excel or my calculator, then it will make it a lot quicker, and it'll be less work if I'm just pressing buttons. But not all matrices represent systems of linear equations. If I see a matrix, a table with numbers, it probably doesn't represent a system of linear equations. In this section, we're introducing matrices, and every matrix that we're going to create in this section will represent a system of linear equations. Once we get to section 8.3, we're going to be giving more matrices, or matrices, and those won't represent systems of linear equations. So when I look at a matrix, I call it by its size. So let me just do 1, 2, 3, 4, 5, 6, 7, 8. This is an example of a matrix because it's just a table of numbers. Usually we put square brackets at the edges to encapsulate those closed numbers, and if I don't see those square brackets, then I probably think it's probably not a matrix. And we define a matrix by its size. This matrix has, I would say, 2 rows. This is going to be row 1 and row 2. So going horizontally, these are rows. So this is the first row of this matrix, and this is the second row. And 4 columns. rows run horizontally, columns run vertically. So this matrix that has 2 rows has 4 columns, and I'd say this is a 2 by 4 matrix. A lot of times we replace that word by with a cross. I'll say it's 2 by 4 with a cross. Here's another matrix. This matrix has 4 rows. Row 1, row 2, row 3, and row 4, and 3 columns. This would be column 1, column 2, and column 3. This is a 4 by 3 matrix. So a matrix is just a table of numbers. The matrices can represent systems of linear equations, but they don't always. These random matrices don't probably represent anything in reality. Alright, so that's already 7 minutes. Let me just jump into the section. And all through section 8.1, I wanted to pull my calculator out and show you how to use matrices to solve systems of linear equations to check your answers, because it's really nice. So each of the problems in the first group of problems here have the instructions: solve the system of equations using matrices and row operations. Check your answer using the RREF feature on your calculator. So for each one of these problems, we're going to create first, we're going to create a matrix to represent the system of linear equations. And that's very easy. So I'm going to write a blank shell for a matrix for problem 2. There's my matrix kind of starting. And what I'm going to put in my matrix is just the numbers, the coefficients of the letters, and the numbers to the right of the equal sign. So I'm going to strip down the system of linear equations and just put in it kind of a shell of the problem above. In front of the y in the second equation, there's an implied 1. So I'm going to write 2 rows. The first row is going to be the first equation. It's going to have the numbers 8, -3, and -2. And then the second row is going to have 2, 1, and -4. A lot of times when a matrix represents a system of linear equations like this one does, I put a bar where the equal sign was, and that's one easy way to tell that this matrix represents a system of linear equations. If I don't see the vertical bar kind of separating the letter side from the equal side, then that matrix probably doesn't represent a system of linear equations. So this is the matrix representation. Now I'm going to do 2 things. 1, I'm going to solve on my calculator, and 2, I'm going to solve by hand. To solve this by hand, I have to use the elimination method twice. For solving matrices, we're essentially just going to do the elimination method and not going to do the substitution method. But so first, I'm going to do this, set up my matrix, and second, I'm going to solve using my calculator so I know exactly what my answer is going to be. So that when I go to do it by hand, and that's going to be my third step, solve by hand, and that third step's going to have lots of parts to it, but that way I'll know my answer is right. So the first thing we need to do to solve this on our calculator is we're going to need to enter it on our calculator. And I'm going to enter this as a 2 by 3 matrix on my calculator. Because it has 1 row, 2 rows, and 1 column, 2 column, 3 column. So now to do that, I get my calculator up here. I have my calculator on. In my calculator, the matrix is written in blue above the X inverse key. So I'm going to hit the second button. And the X inverse key, not because I want the X inverse, but because I want the word matrix that's above it. So I hit the blue second and then the matrix key. And in order, there's 3 kind of headings, names, math, and edit. We'll eventually use all 3 headings going from right to left. The first heading I need to use is edit. So I'm going to arrow over next to say edit. And your screen right now could look very different than mine. I've used this to, do matrices before, and I'm not very good at deleting matrices. So I'm going to arrow over to edit, and I'm going to leave it right where it's at right now. The 1 is highlighted, and next to my 1 says matrix A. Mine says 3 by 4. Yours might not have anything there, or might have another dimension. But once you have the edit in the right tab highlighted and the 1A highlighted, you're going to hit enter. And that's going to take me into matrix A. So when I'm going to hit enter right now, it takes me into matrix A. And now I'm just going to type everything that I want to enter for this matrix. This is a 2 by 3 matrix. My matrix A before was a 3 by 4. If I just type 2, that 3 is going to disappear and turn into a 2. I'm going to hit enter, and it's going to jump over to the 4. I'm going to type in 3, and it's going to give me now a matrix that is a 2 by 3 matrix, and all I'm going to do is enter the numbers. When I use a negative, it's the negative in the bottom row of my calculator as opposed to the minus sign. So now I'm just going to go 8, enter, -3, enter, -2, enter, 2, enter, 1, enter, -4, enter. So then I'll just, the next step here is just going to create the matrix. So super important to double and triple check to make sure you've got this right. So I have 8, -3, -2. I'm just using my arrow buttons. 2, 1, -4. Done with that. So now I have the matrix in. So all this right here was to get the matrix entered. So we need to enter the matrix first. So all this second in matrix, edit, so all that got me to being able to enter this matrix. After I get the matrix entered, I want to simplify the matrix using something called RREF, means reduced row echelon form. Under the Math tab. So right now, my calculator, I just entered the matrix. I've entered the matrix. Now I want to be able to simplify the matrix. And once I simplify it, I'll be able to tell the answer. So once the matrix is entered, you're going to hit second, and then the mode quit key. Seconds in blue, and right next to the second key, there's the mode quit key. So I hit my second, and then my quit key. It takes me back to the main screen. And I'm going to need to go back into the matrix screen by hitting the second X inverse matrix key. So second X inverse matrix. And this, the last time I arrowed over to edit, this time I'm going to arrow over to math. So I'm going to get the math highlighted in the middle. And I didn't have to do anything with the column because the column was on A before. Now I'm going to have to do something with the column. I need to arrow down forever to get to letter. For my calculator, it's letter B. So I have letter B. It has a down arrow next to it. And it says RREF parentheses. So on this second step, so where I was at, I was in my matrix. I had entered my matrix. I hit second and the mode button to get out of the matrix. Then I hit second and X inverse to get into my matrix screen. I arrowed over to math, and now I'm going down to RREF, which is letter B, and then I'm going to hit enter. And what this is going to do is on my main screen, it's going to go RREF with the parentheses on my main screen. And my main screen is cleared out, so that's the only thing you're going to see. It could be at the bottom of your main screen. So I'm almost done. I'm going to simplify the matrix using RREF. I'm not quite done because it's going to reduce the matrix, any matrix I tell it to reduce. And the matrix I'm going to tell it to reduce is matrix A. So I need to get right on my main screen next to the A, or next to the RREF, the matrix that I put this in, and I put this in matrix A. To do that, I have to do a third time, second in matrix, or the X inverse key, to get the A here. So now I'm going to go second in matrix a third time, and I'm going to leave my calculator on names in the left column, and on A1 in the middle column, and hit enter. So it puts me right where it needs to be. So first time I went to edit and was able to enter the matrix. Second time I went into the matrix, I went to math to get the RREF. Third time I need the names of the matrix. I put my matrix in matrix A. I'm going to hit enter and then enter again. So it's going to be enter and then enter. When right now on my main screen, my calculator is prepared to reduce matrix A. I'm going to close out the parentheses so I don't really have to do that. And when I hit enter, it's going to reduce the matrix and give me something that I'll be able to quickly read my answer to. So I'm solving using my calculator. I did all the calculator steps right now. Lastly, I need to interpret my calculator's work. I'm going to get my answer. By interpreting my calculator's work. So my calculator gave me 1, 0, negative 1, 0, 1, negative 2 from the initial matrix of 8, negative 3, negative 2, 2, 1, negative 4. My calculator is not going to put that vertical line where the equal sign is, but I'm going to put that vertical line back so I know where the equal sign is. And I know that when I created this matrix, that the first column was the coefficient of the x's, the second column was the coefficient of the y's, and the last column was the number in the equal signs. What I'm going to do with my calculator's work is create a system of equations. I'm going to go backwards. I'm going to do exactly the opposite of what I did on the very first step. On the first step, I took a system of equations and created a matrix by pulling off the x's, the y's, and the numbers in the equal column. I'm going to do exactly backwards now. So I'm going to create a system of equations from this matrix. The first row is going to say 1 times x. No sign there, so I need a plus sign. If it was a minus there, I put a minus sign. Plus 0 times y, and this bar is my equal sign, equals -1. And the second one's going to say 0 times x plus 1 times y equals -2. The nice thing about the first equation is it simplifies. 1x is just x, 0y is just 0. It simplifies to x equal -1. The second row, the 0x cancels. This gives me y equals to -2. The answer, when you do a matrix in RREF, is generally just the numbers in the right-hand column, unless it's a no solution or infinitely many solutions, and we'll get to those later. All right, 21 minutes and I haven't done any algebra. So what we've learned how to do is we've learned how to take a system of linear equations, rewrite it as a matrix, enter that matrix on my calculator, simplify that matrix so that I can look at something that's equal to in terms of solution to the original matrix and get my answers to a system of equations. That's a beautiful thing to be able to do. Now we need to be able to do this by hand. I'll teach you the calculator a few more times, but not yet. Now I'm going to solve this by hand. And in order to solve this by hand, it's very important that you follow my steps precisely. So I'm going to solve number 2 by hand using matrices. And to do this, I'm going to start off with my initial matrix. It's going to be my matrix 1. That was 8, -3, -2, 2, 1, -4. And very specifically, you should have your work will create 2 more matrices. The last one's going to be the answer matrix. And I will need to use the elimination method twice as well. So each time I do the elimination method, I'm going to create a matrix. So step 1 is use the elimination method to eliminate the x's, and the x's are in this column. Put your answer in the bottom row of the second matrix. So I'm going to have, for this problem, this is my first matrix. I'm going to have a second matrix and a third matrix. The third matrix is going to be the one that matches my calculator. To get a matrix, I need to use the elimination method. So what I'm going to do is take this matrix, the 8, -3, and -2, and 2, 1, and -4, and eliminate the x's. And to eliminate the x's, I need the same number in front of each of the x's with different signs. I'm going to multiply this bottom equation by -4 to do that. So my initial matrix, I'm going to treat it just like I'm doing the elimination method, but I'm not going to have letters. I'm going to multiply every number in the bottom row by -4 and eliminate the x's by adding them together. I'm going to go -4 times 2 is negative 8. Negative 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16. I'm going to add these together and get 0, negative 7, positive 14. Each one of these numbers is divisible by 7, so I'm going to divide. I'm actually going to divide by negative 7, just like when we were doing the algebra for solving systems of equations. If I got a row or an equation that all the numbers were divisible by the same number, I usually did that division. So I'm going to go 0 divided by 7 is 0. Negative 7 divided by 7 is negative 1. 14 divided by negative 7 is negative 2. This right here is going to be the bottom row for my second matrix. And I'm going to get 3 matrices in my algebra. This is the second one. So what I'm going to do to create my second matrix is I'm only going to change one row. My second matrix is going to have a new bottom row. The bottom row is going to be 0, 1, and negative 2. The top row doesn't need to change. It's going to stay at 8, negative 3, and negative 2. For the rest of time, I'm not going to look at that matrix 1 again. So I'm going to move on to my second step here. I'm going to use the elimination method to eliminate the y's. And I'm going to put my answer, or your answer, in the top row. Of the third and final matrix. So I'm going to use my elimination method. I'm going to take the 2 rows, the 8, negative 3, and negative 2, and 0, 1, negative 2, and eliminate the y's. And I'm going to eliminate the y's by making the y's have positive and negative 3 in front of them. So I'm going to multiply the bottom row by 3. I'm going to leave the top row 8, negative 3, and negative 2. And then I'm going to go 3 times 0 is 0. 3 times 1 is 3. 3 times negative 2 is negative 6. And I'm going to add 8 plus 0 is 8. Negative 3 plus 3 is 0. Negative 2 and negative 6 is negative 8. When the numbers have the same signs, you add and keep the sign. And now I'm going to divide every number by 8 because I can do that to make the numbers smaller. Without impacting my answer. So this is going to be the top row of my third and final matrix. So my third matrix, the top row is going to be 1, 0, negative 1. The bottom row is going to be the 0, 1, negative 2. I'm only changing one row at a time. Put that sign in. If you remember what our calculator gave us, that's exactly what our calculator gave us, so I'm done. And now I just read this off as an answer. And we did reading off the answer, so I'm going to just repeat that. I'm going to say the answer is x equal to negative 1, y equal to negative 2. I don't need to check this because my calculator came up with the same answer, so I feel good about my work. Alright, so I'll flash your number 1 up there. I'll do number 4. If you're not ready to jump into these yet, that's completely fine. You can watch me do number 4, and that might get you motivated. So for number 4, I'm going to do all my calculator work first. So this is your number 3. I need lots of room here. So I'm going to do the calculator part of number 4. So I need to create a matrix, and that's easy. I just pull off the numbers that are in front of the letters. If there's not a number, it's implied 1. So I'm going to have that, that, and that. And my matrix here is going to be 5, 2, 1, 1, negative 7, 10. Put a bar for that equal sign. It can be dashed, doesn't have to be dashed. And now I'm going to enter this matrix on my calculator. So, first step in entering this on my calculator is hitting second and then the matrix X inverse key. So to enter this on my calculator, I go second and the X inverse key, and then I arrow over to edit, and I have the 1 and the A highlighted, and I hit enter. So I did second matrix, arrowed over twice to edit, and I'm going to hit enter because the edit is highlighted and the 1 is highlighted. When I hit enter, I'm going to type this matrix, which is a 2 by 3 matrix. Again, it has 2 rows and 3 columns. So I'm going to go 2, enter, 3, enter. Just type all the numbers now, followed by an enter. 5, enter, 2, enter, 1, enter, 1, enter, negative 7, enter, and 10, enter. So I've created the matrix. I did second inverse matrix, second matrix, went over to edit, hit enter, and I was able to enter the entire matrix. Once you're done entering the matrix, you have to hit second and quit. And that's what I'm into next. So next I'm into my middle part here. I'm going to do the math on the matrix. And the math on the matrix needs me to do second and quit, and then second matrix, arrow over to math, and then all the way down to RREF with a parentheses. That's a parentheses and not a C. Went to RREF with my parentheses. Now I'm going to hit enter. And then I'm going to go second matrix and then have the names in the A highlighted like they are and hit enter, enter. Oh, okay, it gives me a nasty decimal. To make a decimal into a fraction, we've done this before, you hit math and enter twice. So math, enter, enter. And I'm going to get this horrible number, 1, 0, 27 over 37, and 0, 1, negative 49 over 37. I'm going to double check to make sure I actually entered the matrix right, because I'm surprised I would get a fraction answer here. So let me do second matrix, edit, 5, 2, 1, 1, negative 7, 10. It just looks completely right. Unfortunate, but that's fine. So I'm done with my calculator. The top row says 1x plus 0y equals to 27 over 37. And so I'm going to get x equal to 27 over 37. The second row says 0x plus 1y equals negative 49 over 37. And so I'm going to get y equals to minus 49 over 37. Done with my calculator. My answer to this, problem 4, is going to be x equal to 27 over 37, y equal to negative 49 over 37. Now by hand. So doing a matrix by your calculator alone is absolutely not going to get you any credit on the test, because that, I can teach my 8th grade nephew to do that. So now by hand. Using matrices means I have to do the elimination method twice. And each time I do the elimination method, I'm going to produce a new matrix. So this is my first matrix. I'm going to have a second and a third matrix. My step 1 is to eliminate the x's and put the result in the bottom row of my second matrix. So I'm going to take the matrix that has 5, 2, 1, 1, negative 7, and 10, and I'm going to eliminate the x's by getting the x's to have both a 5 and a negative 5. That's kind of the strategy that we learned in the last section for doing the elimination method. I'm just doing the elimination method, but I'm stripping out the letters. So I multiplied negative 5 times 1, negative 5 times negative 7, negative 5 times 50. Now I'm going to add and get 0, 37, and negative 49. None of those numbers are divisible by anything nice, so I'm going to write that for my second matrix. My second matrix is going to have a new bottom row, but it's not going to have a new top row. The top row is going to stay 5, 2, and 1, 0, 37, and minus 49. Step 2, this is going to be ugly. I'm going to need my calculator. I'm going to eliminate the y, and I'll put the result in the top row of my third / final matrix. So I'm going to take the two rows of my matrix, 5, 2, and 1, 0, 37, and negative 49, and I'm going to eliminate the y's. And this is the y's have the same signs and numbers that aren't multiples of each other. When there's no relationship between the numbers in the column, you can just multiply each row by the other number and make sure to get your signs right. I'm going to multiply the top row by 37 and the bottom row by negative 2 to eliminate my y's, because 37 times 2 in both of them is going to give me a 74. So first computation is 37 times 5. And 37 times 5 is 185. Then 37 times 2, you get 74. And then 37 times 1, you get 37. Next row, negative 2 times 0, you get 0. Negative 2 times 37, you get negative 74. Negative 2 times negative 49, doing these off screen, is 98. Now I'm going to add these together. 185 plus 0 is 185. 74 and negative 74 is 0. 37 plus 98 is 135. If I would have noticed all these are divisible by 5, it would be nice. I'll pretend I didn't know it. So that's going to be the top row of my final matrix. So I'm going to make my third / final matrix, or almost final matrix, so it doesn't look like my calculators just yet. My top row is going to be 185, 0, and 135, and then the bottom row is going to stay 0, 37, and negative 49. And if you look at my calculator's answer, trying to get it back up because I was doing some work off screen. So let me get my, hold on. So my calculator's answer was this, and if you look at my answer, it doesn't look the same. So what you need to have is the numbers in the X and the Y columns to only be zeros and ones. And I have 185 in an X column, 37 in a Y column. If my algebra has a fraction answer, I need one extra step. And my extra step is going to be to clean the rows up by dividing to make the number in the x column a 1. So I'm going to divide everything in the top row by 185 to get the number in the x column to be a 1. And I want to make the number in the y column a 1 for its row. So I have an extra step to get to my calculator's answer. Now I'm going to get to my real final matrix. This is a final matrix, but it's not a final matrix that I can read the answer from, so I'm going to modify that by just division. Final in terms of I don't have row operations to do. So here, 185 divided by 185 is 1. 0 divided by 185 is 0. And then 135 divided by 185, and I go math, enter, enter, is 27 over 37. Second row, 0 divided by 37 is 0. 37 divided by 37 is 1. And that I know doesn't reduce because when I did this on my calculator, I got that matrix. So now it's exactly like my calculator's answer matrix, so I can say my answer is 27 over 37 for x and negative 49 over 37 for y. All right, so give problem 3 a go, and I'll move on and do number 6. And I'll progressively do less explanation because these problems take so long. It's going to be a 3-hour section by the time I'm done. And these are the easy problems because I only have to do the elimination method twice. Once there's 3 equations and 3 unknowns, you have to do the elimination method 6 times, and that's really not good. So for problem 6, I'm going to do all my calculator stuff first. I always, if I'm asked to solve using matrices, a system of linear equations, I do my calculator work first. The matrix I'm going to have is going to have 4, 1, 11, 3, negative 5, and 37. I'm going to enter this in matrix A as a 2 by 3 matrix. So I'd go second x inverse for matrix, over to edit, type 2, enter, 3, enter, then 4, 1, 11, 3, negative 5, 37. So I did second matrix, edit, typed in 2, enter, 3, enter, entered all the appropriate values, and now that I have it entered, I hit second and mode for quitting to get out of the matrix. Let me clear this main screen by just hitting clear. Now second matrix, first to edit, second to math, and when you go to math, you go down to RREF, hit enter, and then second matrix, now name. So first edit a 2 by 3 matrix, math, RREF, names, you leave it right in A and hit enter, and then enter again. So the matrix I'm going to get is 1, 0, 4, 0, 1, negative 5. The top row says 1x plus 0y equals to 4, so it really says x equal to 4. And the bottom row says 0x plus 1y equals negative 5, so it really says y equal to negative 5. And my answer is going to be x equal to 4, y equal to negative 5. That's the easy part. It's not really hard to do it by hand, it's just tedious. If I was, given this system of equations, I would never use matrices to solve a system of equations by hand. But since I have technology, I'd use my technology. If I was given the choice of solving this by hand using what we did in section 8.1 or solving it using matrices and I could use my calculator, I'd use my calculator. If I was forced to do it by hand, I wouldn't use this method, the matrices. But we have to learn it because if you take Math 218, you do matrices in there and you need to know these. So to do 6 by hand, it's elimination method 2 times and creating 3 matrices. So my first matrix is going to have 4, 1, 11, 3, negative 5, 37. Step 1, eliminate the x's, put in bottom row of second matrix. So the two rows are 4, 1, 11, 3, negative 5, 37. And to eliminate the x's, I need a positive and negative 12 in front of my x's. I'm going to multiply this row by 3 and this by negative 4. So I'm going to go 3 times 4 is 12. I probably shouldn't have the matrix written here. It's okay though. 3 times 1 is 3. 3 times 11 is 33. Negative 4 times 3 is negative 12. Negative 4 times negative 5 is 20. And then 4 times 37, or negative 4 times 37 is negative 148. I'm going to add these together. 12 and negative 12 is 0. 20 and 1 is 21. And then 148 and 33, that's negative 115. Evidently, I can divide all these by 21. Let me try to go divide it by 21, divide it by 21, divide it by 21. This is going to give me 0, 1, and then when I do negative 115 divided by 21, hey, means I have a math error here, huh? 3 negative 4, 1, 11 times 3, 12. Oh, this should be 3. Look what I did right here. I went 3 times 1. I didn't write a 3. I left it as a 1. So that should have been a 3 here, which means this row should have been 0, 23, negative 115. I know that I want the bottom row to be 0, 1, negative 5. And I thought that was going to be a negative 5. It wasn't. So I went back and found my mistake. That's nice having the calculator answer ahead of me, because now I knew my bottom row was supposed to be no fractions in it. And when I divided by 21 and got a fraction, I knew I messed up. So I went back and found my mistake before I got too far. So now my bottom row is going to be 0 divided by 23 is 0, 23 divided by 23 is 1, and then negative 115 divided by 23 is negative 5. So in my second matrix, I'm going to put that as its bottom row. So ready to write my second matrix down. My second matrix is only going to have a new bottom row. The top row is going to stay 4, 1, and 11. The bottom row is going to stay 0, 1, and negative 5. And now I'm going to eliminate the y, put in the top row of my third / final matrix. So I'm going to take the 4, 1, 11, 0, 1, negative 5, eliminate the y's. I'm going to do that by multiplying this row by a negative 1. It's going to make me have a 1 and a negative 1 in front of the y's, and they'll cancel. So I'll leave the top row temporarily at 4, 1, and 11. Negative 1 times 0 is 0. Negative 1 times 1 is negative 1. Negative 1 times negative 5 is positive 5. I add these together and get 4, 0, 16. All those numbers are divisible by 4, so I'm going to go divide by 4, divide by 4, divide by 4. That's going to give me 1, 0, and 4 for the top row of my final matrix. So my second matrix, I'm going to change this top row. And when I change that top row, my third matrix, which is my answer matrix, is going to have a top row of 1, 0, and 4, and a bottom row of 0, 1, and negative 5. And I can read that off as my answer, and we read off the answer earlier, so I won't do that again, as x equal to 4, y equal to negative 5. So they're very repetitive. They take a long time to do, but if you keep the structure, Create your matrix, eliminate the x's, put that in the bottom row, eliminate the y's, put that in the top row. They're not the worst thing that we do. So there's your problem 5. I'll move on to 7 and 8. So my 8, I'm going to start off doing my calculator work. The matrix I'm going to enter is 4, -3, 10, 2, 1, and 10. So onto my calculator. Clear out that main screen. It's just kind of nice to have that cleared. Second and X inverse our matrix. First time I use edit. Second time math. Third time's names. So I'm going to go edit on A. Hit enter for 2, enter for 3, and then type in 4, -3, 10, 2, 1, and 10. Done with that. Now second and quit. And then second in matrix a second time. First time was edit, second time was math. After math, you go down to RREF, hit enter, and then second in matrix a third time. On names, you hit enter, then you hit enter again. And my calculator gives me the matrix 1, 0, 4, 0, 1, 2. I'm going to interpret that. The top row says 1x plus 0y equals to 4, which means x equal to 4. And the bottom row, if I put the x's and the y's and the signs in, I get 0x plus 1y equal to 2. And that simplifies to y equal to 2. So my answer is going to be x equal to 4, y equal to 2. Now, by hand. By hand, I do the elimination method twice. So by hand, my first matrix. Notice I didn't put the line in. It's nice if I put this line in, but it's really not necessary. So I'm going to eliminate the x's and make a new bottom row. So I'm going to take the 4, -3, 10, 2, 1, and 10 and eliminate the x's. I'm going to multiply the bottom row by -2 to make the x's drop out. So I'm going to get 4, -3, and 10, and -4, -2, -20. This is going to give me 0. When the numbers have the same signs, you add them and keep the sign. When the numbers have opposite signs, you subtract them and take the sign of the larger. So I get 0, -5, -10. I'm going to divide all of these by -5. When I don't have fraction answers, I should be able to divide out and get a really nice row. So 0 divided by -5 is 0. -5 divided by -5 is 1. 10 divided by -5 is -2. I'm ready now for my second matrix. And that's going to be the bottom row of my second matrix, which means the top row doesn't change. It stays at 4, -3, and 10. And now the bottom row is going to be 0, 1, and -2. I need next to eliminate the y's and make that a new top row. So I'm going to take the 4, -3, and 10, 0, 1, and -2, and eliminate the y's. This is my y column. I need to make these numbers cancel. I'm going to do that by multiplying by 3, the bottom row. I'm going to make the top row 4, leave it 4, -3, and 10, and then 3 times 0 is 0, 3 times 1 is 3, 3 times -2 is -6. This is going to give me 4, 0, and 4. I'm going to divide all these by 4. 4 divided by 4 is 1. 0 divided by 4 is 0. 4 divided by 4 is 1. I'm going to put that in my new top row of my third and final matrix. So ready for my third / final matrix. My third and final matrix, its top row is going to be 1, 0, 1. Its bottom row is 0, 1, negative 2. So my answer that I already generated when I did the calculator work is going to be x equal 1, y equal negative 2. Let me just peek back here and make sure when I actually did that by hand. Look at that, I got 4 and 2 for an answer. Ugh, what did I do wrong? I see my mistake. So look at this. I wrote down an answer, and I went back and checked my calculator, and my calculator says the answer is 4 and 2. I have the answer 1 and negative 2. Bad, 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 but I can find my mistake. When I have a mistake, I can find it, and I've already found it. So I already had the wrong answer for y, so my mistake is when I tried to find the y. When I got y equal to negative 2, that's from this row right here. Look at the mistake that I did. I did negative 10 divided by negative 5, and I wrote down negative 2. That's not good. I should have written down positive 2. So you're going to have this happen when you do matrices all the time. You're going to make a mistake. The earlier you catch the mistake, the less pain you're going to cause yourself fixing the mistake. So I'm going to fix the mistake, and this is something you're probably going to go through a lot. So this negative 2 should be a 2, and let me just redo the problem after that. So I found my mistake, and now I'm just going to redo the problem. I'm going to create my third matrix by dropping the y's and making a new top row. So I'm going to put my fixed matrix 4, negative 3, and 10, 0, 1, and 2, and I'm going to drop the y's by multiplying this row by 3. I'm going to leave this 4, negative 3, and 10. I'm going to go 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6. I'm going to add these. 4 plus 0 is 4, negative 3 plus 3 is 0, 10 plus 6 is 16. I'm going to divide by 4. I'm going to get 1, 0, and 4. That's the top row of my final matrix. So my third and final matrix its top row is supposed to be 1, 0, 4. Its bottom row is supposed to be 0, 1, and 2. And now I can fix my answer. My answer is supposed to be 4 and 2. Notice once I found my mistake, I did my work all over on a clean sheet of paper after that mistake. That's probably the best thing to do, to try to go through and fix your mistake, the horrible answer of 1, negative 2 that was wrong. To fix my mistake by going through and crossing out each one of my mistakes is probably going to cause you a lot of grief. So I knew my y was supposed to be 2. When I went back to my answer sheet, I seen a y of negative 2. Once I isolated the mistake, I started completely over. I covered up my work, and I started over. Okay, now to get from my second to my third matrix, I take the correct second matrix, drop out the y's, make it a new top row, and then I just finish the problem up. That's probably the best strategy. Better strategy would have been not to go further. Since I know that the y was supposed to be 2, I should have never, ever, ever let that go. I should have, right there, that should have been a 2 right there. I should have not gone on to the third matrix until I had my second matrix as right as I can make it. So there's your problem 7. And we have 2 more problems for this video. Ugh. Okay, calculator 10, calculator work. Maybe we'll just do one more each for this video and skip problems 11, 12. So my calculator is going to have a 6, 2, 26, 2, negative 7, 24 matrix. So on second matrix, edit, 2, enter, 3, enter. Just enter these things up. So I have everything in properly. Then second quit, second matrix math. So first edit, second math. When you go to math, you go down to RREF and hit enter. And then second matrix, first edit, second math, RREF, third names A, enter and enter. Beautiful. So my final matrix should be 1, 0, 5, 0, 1, negative 2. Top row says 1x plus 0y equal to 5. So that means x equals to 5. Bottom row says 0x plus 1y equal to negative 2. That simplifies to y equal to negative 2. My answer for problem 10 better be 5 and negative 2. I get the y answer first. If my y answer isn't negative 2, I should stop and make sure I get it there so I don't have to go way, way back to find my mistakes. All right, so now by hand. So by hand, it's not so hard. It's tedious, but it's just the elimination method. So 10 by hand. My first matrix is 6, 2, 26, 2, negative 7, 24. I could divide everything in that row by 2, but I'll pretend I didn't notice that because that doesn't happen that often. So I'm going to eliminate the x and make a new bottom row. So I'm going to take this 6, 2, 26, 2, negative 7, 24. To eliminate the x's, I'm going to make that 2 into a negative 6. I'm going to multiply everything by negative 3 in that bottom row. I'm going to leave the top row 6, 2, and 26. I'm going to go negative 3 times 2 is negative 6. Negative 3 times negative 7 is 21. Negative 3 times 24, I'm doing it off screen on my calculator because I'm afraid I'm going to mess up, is negative 72. 6's cancel. 21 plus 2 is 23. These numbers have opposite signs, so you have to subtract 72 and 26, and I'm going to get negative 46. Again, I could do that. I should do that on my calculator. Go 26 minus 72 is the negative 46. And now I'm going to divide by 23, divide by 23, divide by 23, and get 0, 1, and then negative 46 divided by 23 is negative 2. That's beautiful. That's the row that I needed to have. So now I'm going to write down my second matrix. My second matrix has a new bottom row, but the top row doesn't change. It can stay at 6, 2, and 26, and I have 0, 1, and negative 2. On to my third matrix. I have to eliminate the y and make a new top row. So I'm going to put this 6, 2, 26 on top of 0, 1, negative 2. I'm going to make the y's cancel by making this bottom row have a negative 2 to cancel with the 2. So I'm going to multiply by negative 2 in the bottom row. I'm going to leave the top row 6, 2, and 26. I'm going to go negative 2 times 0, negative 2 times 1, negative 2 times negative 2. I'm going to go 6 plus 0 is 6, 2 plus negative 2 is 0, 26 plus 4 is 30. All these numbers are divisible by 6, so I'm going to divide them by 6. When I divide them by 6, I get 1, 0, and 5. And my calculator gave me that row, so I did it right. And now I'm going to do my final matrix. My final matrix has a new top row. It's my third / final matrix. The top row is going to be this 1, 0, 5. The bottom row is going to be 0, 1, negative 2. And my answer, I already did the answer to this, so I knew the answer is going to be x equal to 5, y equal to negative 2. All right, that's only 5 problems. Just better part of well over an hour to do. Here's your problem 9. If you want to stop there for this part, you can. If you feel you need more practice, you could do number 11 as well. The next group of problems is working with the X, Y's, and Z's. And it's significantly more challenging because instead of, like, when you have X's and Y's, you do the elimination method twice by matrices to get your answer, and that's not ridiculous. When we do X, Y's, and Z's, we have to do the elimination method 6 times. So take a good break in between these parts.